Hello students, welcome back. Let us get started with a new topic of chapter 13. This is going to be volume of cylinder. So prior to this we have learnt about volume of cubes and cuboids. What did we learn? That the volume of cube is side cube and volume of cuboid is length into breadth into height. So it was nothing but base area of the cube or cuboid into height. Now just like cubes were, let's say the cuboids were made of many rectangles placed on one on top of the other like this, right? So we had many rectangles placed on one on top of the other. Similarly, cylinders can be counted as many circles placed on one top of the other. So this is one circle, this is another circle, circles of equal area placed one on top of the other. So this will give us a cylinder, right? So if you just look at the borders, what are you getting? You're getting a right circular cylinder. So what is the volume going to be? It's again going to be the same, that is base area into height. So the base area would be the area of a circle, which is pi r square, and height, let's say it is h, so it would be into h. So the volume of cylinder, right circular cylinder, is base area into height, which is pi r square h. So let's write this down. Volume of cylinder is base area into height. So the base area is a circle, therefore this is going to be pi r square, and into height, therefore volume of cylinder is pi r square h. That's about it. So all your questions are in this exercise 13.6 is going to be based on this formula and a little bit of twist and turns here and there. But before we get started with 13.6, let's take a look at the solved examples before it. So I'll start with the question on page 229, solved example number 13. It states that the pillars of a temple are cylindrical with the following dimensions. It has base radius r, that's 20 centimeters, and height h, 10 meters. You need to find out how much concrete mixture is required to build 14 such pillars. So first of all, when I talk about concrete mixture and building and making pillars, I am going to take into consideration the volume and not the surface area, because the volume is going to give you the amount of space the pillar is going to occupy, right? So we have to not just take into consideration the boundaries, the curved surface area and the base and the top boundaries, but also what is lying within. So we are going to find the volume of one such pillar and multiply it with 14, because we need to find the volume of 14 pillars. So let's get started. It's very simple. We just have to apply the formula for volume of right circular cylinder, which is pi r square h. So I'll say solution. And once again, why are we finding the volume of the cylinder? Is because this pillar is going to be completely filled. So whenever something is completely filled, like let's say you have a utensil, remember we learned about solid and hollow objects. So this one is going to be a solid object. So we're going to find the volume. This entire pillar is going to be completely filled with concrete, right? So first of all, I'll say volume of one cylinder is equal to pi r square h. Here we've been given with the radius in centimeters and height as meters. So here itself I'm just writing this as, or rather we will just convert that value for height into centimeters out there. So I'll say 22 upon 7 into r square, which is 20 square into 10 into 100. Why? Because 1 meter is equal to 100 centimeters, therefore 10 meters is going to be 10 into 100 centimeters. So now this makes our entire equation into centimeters. So this is going to be 22 upon 7 into 20 into 20 into 1000. 1000 centimeter cubes. So this is the volume of one cylinder, therefore volume of 14 cylinders is going to be this entire equation into 14. So I'll say therefore volume of 14 cylinders is equal to 14 into 22 upon 7 into 20 into 20 into 1000. So this is 7 ones are 7, 7 twos are 14. Now simple calculation, 2 into 22s are 44, and 44 into, let's say, 2 into 2, that is 4. So 44 into 4 would be 4 4s are 16, 4 4s are 16, 17. So 176, and how many zeros? 1, 2, 3, 4, 5. This is centimeter cube. It's better that we convert it into meter cube, right? So now we know that 1 meter is equal to 100 centimeters. Now this is in cubes, so I'm going to say, see, the volume is always going to be into unit cubes. Therefore 1 meter cube is going to be 100 centimeter, the whole cube. So the cube of 100 is going to be 1, 2, 3, 4, 5, 6 centimeter cubes. So now 1 meter cube, I'm going to use unitary method. 1 meter cube is equal to 1, 2, 3, 4, 5, 6 centimeter cubes. Therefore this digit out here, 176 and 5 times 0 is equal to x. Let's cross multiply x meter cube. So when you cross multiply, you get x meter cube is equal to 176 5 times 0 divide by 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it is 176 upon 10. We need to get rid of this 0 in the denominator. So we are going to shift towards the left by 1 decimal place in the numerator. So finally what do we get? 17.6 meter cube. So x is equal to 17.6 meter cube. So finally, how much concrete mixture is required to build 14 such pillars? I'll write the answer here itself. I'll say 17.6 meter cube. So please take a look at the solution. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.